In this example, we're going to practice using some business formulas along with thinking about average profit rather than total profit and how we can calculate that. So in example 3, we've got a price demand equation for the production and sale of X umbrellas per week is given by P equals 25 minus 0.01X. And the cost function is given by C of X equals 2X plus 9,000. So for part A, all I want to do is find the profit function. Now, if I think about my profit function, we said earlier that you can find your profit function by taking your revenue function minus your cost function. Well, we have the cost function. That's not a problem. But we're missing the revenue function. We don't actually have that. So before we can do anything else in this problem, we got to find the revenue function. Now, the revenue is how much money that we make in the sale of whatever it is that we're selling. In this case, it's umbrellas. So revenue depends on two things. It depends on the price that you're selling the thing at. So, okay, this thing costs $5. So it depends on the price that you're selling it at, and then the quantity of how many you sell. So it depends on how many of the things that you sell. So we're going to take the price of the thing we're selling and multiply it by the quantity, the number of things that we sell. To shorten this up here, my revenue function R of X is equal to price. How about we call that P, because we have a price demand equation right here. So P times the quantity, well, X represents the quantity, X umbrella. So I essentially just have R of X equals P times X. Well, shoot, I have the price demand equation right here that was given to me. That was 25 minus 0.01x. So I'm going to plug that in for my price. So 25 minus 0.01x times my cost function, not my cost function, my quantity, which quantity is just x. So I have the price here, 25 minus 0.01x, times the quantity, which is just x. This is relatively easy to simplify. We just need to distribute here. We end up with R of X equals 25x minus 0.01x squared. So there's our revenue function. And now we can go ahead and plug that into our profit function so that we can find that. So our profit function, P of X, is our revenue function that we just found. 25x minus 0.01x squared minus the cost function that was given to us. So minus 2x plus 9,000. Again, please make sure that you use parentheses around your cost function because I want to subtract both of these two terms. If you don't include those parentheses, you're only going to subtract the first term. We want to subtract them both. So our profit function, P of X, is given by, let's distribute that negative sign. So let's make this minus a plus, and then we'll change the signs here. So I should end up with negative 0.01x squared. Let's see, I've got 25x plus negative 2x. That'll be plus 23x. And then plus negative 9,000, we'll just say minus 9,000 here. So here is our profit function. So our profit function, negative 0.01x squared plus 23x minus 9,000. Now, in part B, I want to find the average profit function. So the way we write the average profit function, we write P of X, but then we'll put a little line over it, and that says P bar of X. And the way we find an average, if we think about it, if you were just to find the average of a set of numbers, you would add them all up. In other words, you would total them all up. So I want to take the total profit, which is P of X, And then you divide that by how many things you added up. So I'm going to divide that by the number of units that I manufactured, X. So I'm going to take my profit function that I found, negative 0.01x squared plus 23x minus 9,000, all divided by x. Now, we could perhaps simplify that a little bit if you wanted to. We could take each one of these terms and divide them by x. But in this particular problem, I don't think it's really going to help us all that much. We'll see another example in just a minute here where it might help to simplify it. But if all I'm looking for is the average profit function, right now, I wouldn't do anything else. I would just say, you know what, there it is. In part C, all I want to do here is find and interpret the average profit from the production and sale of 1,500 umbrellas per week. So remember, that is our X value. X represents our quantity. So I'm going to take 1,500 and plug that into my equation for P bar that I found in part B. So P bar of 1,500, that's equal to negative 0.01 times 1,500 squared plus 23 times 1,500 minus 9,000, and then divide that result by x, which is 1,500. So let's see, let me look at my numerator first, negative 0.01 times 1,500 squared plus 23 times 1,500 minus 9,000. Here I ended up with 3,000 in my numerator divided by 1,500. This looks like it simplifies really nicely to $2. So this tells me the average profit per unit. So because we divided by, if we scroll back up, we divided by X, which was the quantity. It was the number of units that we manufactured. So if I want to talk about what this $2 represents, what this says is that the average profit per umbrella or per unit, umbrella, is $2. So that means for each umbrella that I sell, I'm making a profit of about $2. And that's really all I need to do to interpret the average profit. Average revenue and average cost would be interpreted much the same way. We can just kind of swap out that word profit for revenue or cost, just depending on what the problem's asking us for.